Well, we're going to now turn to our tech corner because this is another good one. Dirk gets to play with some new gadgets sent to him by an equipment or software manufacturer. In this case, we have the wireless LightStar torque wrench and the 600 handheld data collector, both from ASIDatamyte. Together, this combination promises to make torque auditing much easier. So, Dirk, take it away, man.
That's right, Mike. Well, thanks a lot. As Mike said, we're going to look at two instruments today from ASIDatamyte. We've got the LightStar torque wrench, and we've got the 600 data collector. And this is a torque wrench. We'll get into it a little bit. You could use it for production, you could use it as for assembly. That's probably not normally how we'd use it because this is really a precise instrument. It's not really a production instrument. It's really intended for inspectors to go out on the line and check the torque on bolts that have already, or fasteners that have already been put in place. So this is an auditing piece of equipment. Very lightweight. All the controls are right at your fingertips, and we'll get to that in just a little bit. It's Bluetooth enabled, which means that it will communicate wirelessly to the data collector over Bluetooth. And I won't get into how you pair it. We don't need to know if you've ever had a Bluetooth device. Pairing is pairing. We're just going to get right into how you might use it. So I'm going to go first of all into the collector, and I'm going to select what ASIDatamyte calls a route, or a measurement plan, a test plan. And we have one here called seatbelt, and I'm just going to bring that up. And we'll look on the screen here. And you'll see on the screen, the very first thing it asks for is it wants to know who is the operator that's going to be doing this test, because you want an audit trail. You want to know who's doing all this. Now, I could manually enter all this information in, but instead, I am going to scan my name from my employee badge. And now it comes up and it puts my name. There it is. It puts my name in there. And also notice it shows a picture. Get this oriented right. It shows a picture of my test setup. Here's my test setup. Here's a picture. We're seeing a lot of this now. Almost all user interfaces use a visually guided routine to step the operator through the measurements that they're going to take. There's a picture and there's arrows or circles that tell the operator where to go. And this one is telling me go to the first bolt and take a measurement. So that's what I'm going to do. I'll set this down here. I'm going to take my torque wrench, and I'm going to go to the first bolt, and I'm going to test it. Now, I don't know if you saw that. Green light flashed. It told me that I am within the boundaries that I'm looking for. And if I come back up here and look at the screen, we can see that there is my reading, 30.38 Newton meters, I believe, and a little green checkbox telling me that it passed. So now I'm going to go to and it points to the next bolt. So now I'm going to go to the next bolt, and I'm going to do that one. Again, green light flashes. By the way, let me point out, you know how a torque wrench works, of course. It's force times distance. Now, with some torque wrenches, you have to be careful that you pull or apply force on the wrench at the right place on the wrench, otherwise you're changing this distance. That affects the measurement. With this wrench, as long as you're applying force anywhere within this handle, you're going to get an accurate measurement. So it doesn't matter whether I pull here, or how the force is distributed across my hand. Accurate measurement. Let's go to the third bolt, and we'll do that one. And again, light flashes. If I was under or over, I would get a different reading, and hopefully we'll see that on this last bolt. If not, we'll force one. Okay, so let me tighten this one up, and we'll go back in and do this again. So let me over tighten one, and let me go back into my routine again, just because I want to show you what a fail looks like. So again, we're pointing to the first bolt. I'm going to, there we go, whoops. And it failed that bolt. Now I'm going to go ahead and do the rest of them. Whoops, sorry, it's asked me to retake the measurement. Okay, I'm just going to step through these real quick. I just wanted to show you that you do get an actual fail on these. Okay. And so that's what would happen. You would get your red lights down here, and then on the display itself, it would give you an up arrow or down arrow to show you whether you were above or below your measurement. Let's take a look at a couple other things here. I'm going to step back in. I want to show you something else here. Let's go back in, and take another measurement because there's something else. There we go. And now I'm going to view this last measurement that I took because I want to show you something. We go on the screen. So the way some torque wrenches work, or torque validation systems work, is they look for a peak reading on the measurement. The LightStar and the 600 software use something called Smart Wrench. They're looking for something different, and we can demonstrate this by looking at the torque curve on that fastener. So notice it's climbing up. That says I'm pulling on the wrench. I pull, and then notice it flattens out. That is where the nut or the bolt actually breaks free. It starts to turn. So it breaks free from the mechanical forces holding it in place. That is the point that the software records the torque for that bolt, because that ASIDatamyte says that is really the most accurate way for reading the amount of torque that is on that particular fastener at that time. Okay, now the last thing I want to show you is that when you're finished with a run, we've measured 4 bolts, it comes back and it asks you for the operator again. So if I wanted to do another test run or go to another car and take another test run, it's going to come back and ask me to enter my operator name again. Why? Well, imagine what could happen. If we come back to the main camera here, what could happen is that I could be taking measurements and then I get tired. I want to take a break. I hand the wrench over to Mike. Mike starts taking measurements, but the recorder is telling me that it's me. So Mike takes a bunch of measurements under my name. Well, now if there's something wrong, we don't know who took the measurements, right? Did Dirk take them? Did Mike take them? Who took them? So by forcing the operator to have to enter their name each time, scan it or whatever, you always have an audit trail for who is doing what when. By the way, that's the default. That can be turned off. You don't have to run it that way. Personally, I think that actually is a good way to use it. A couple other things. The wrench does not just communicate the torque measurement to the collector. It also communicates all of the information about the wrench, which allows the software to do a couple of interesting things. Number one, the route or the test routine checks to make sure that you're using the right route. So this route is programmed to use a W75 wrench, which is what this is. If I was to pick up a different wrench, a W25, and pair it, and then launch that routine, routine's going to come back and say, hey, guess what? You're using the wrong wrench. So it kind of foolproofs the process for the operator, making sure that they're always using the right tool. The other thing that it does, we'll come back to the gauge cam here. I'm going to go back into the menu. Oh, I can, here we go. Come back into the menu. I'm not totally familiar. Okay, there we go. And we'll go down to our wrench. And we're going to select the wrench that we used, which is that one. And I'm going to point out something really important that shows up on this information. This all comes in from the wrench. Notice the very last column, calibration due in 339 days. And the column just above it is when it was calibrated last. As we've talked about on the show, anytime you pick up an instrument that is calibrated, you need to look at the calibration tag to make sure that you are using an instrument that is within its calibration interval. If it isn't, you shouldn't be using it. This tells the operator what the calibration, when the calibration is due, and if it's within the interval, you should use it. This software doesn't do it, but a new release of the software actually brings up a warning. So even if the operator doesn't check this, they'll get a warning that the wrench that they just picked up is out of its calibration interval and should be calibrated. A couple other things. The data collector itself, very rugged, 4-foot drop to a concrete floor, and it won't break. So for people like me, that's good to know. Wi-Fi connectivity. So once I take all my measurements out on the shop floor, I can go back into the front office, download it onto a computer, and export that data, bring it into SPC software or any other kind of software I want. Just work with the data however you feel fit. There is some basic SPC software also available on the data collector itself. Also, you can upload data into the collector, which means if I want to program some routes offline, I can do that, then upload them into the data collector, and they're ready to go for the next time the operator picks it up. They'll have the latest routines. Barcode scanner. You notice that I scanned my name in. I could also put a barcode on the thing that I'm measuring scan that, and it will load the appropriate test setup. So in other words, I don't have to go through the menu, select which setup I want to run. It's going to do it for me. So again, all of this kind of takes the operator out of it a little bit and makes sure that data entry issues aren't a problem. Finally, I saved this for last because I love cute little things that people do to their products to make them easier to use. If you've ever worked on a shop floor, you know very often the lighting isn't all that good. Then on top of that, you may have to reach inside a recess and it's dark and you're trying to see where to put your tool, find the fastener, and you can't see, so you take out your cell phone and you shine the light in there and you got the tool in your cell phone and you're trying to see what you're doing, right? Well, they thought about that, and so they have put on this a flashlight in the tip. There we go, off, on. Put a flashlight on the tip, they go down. Now you can go into a dark space and you can see what you're doing. Sounds like a simple thing, but it's the simple things like that that just say that they're thinking about the operator, thinking about what happens out on the shop floor. I like that. So if you want more information on either one of these tools, there is a link underneath the player page. This is the LightStar wireless torque wrench and the 600 data collector. There's a link underneath the player page that'll download a PDF. You can get more information, or you can simply go to ASIDatamyte.com, look up the full range of products, including these. So thanks to the guys at ASIDatamyte for sending that on to us. And Mike, back to you.